of Postdoctoral Services, and I'd like to thank CIGCOM for coming to our Managing the Lab seminar this morning, co-sponsored by the Graduate School. Today's seminar, as you probably know, for the graduate student or postdoc, fulfills a responsible conduct of research credit. So if you want that credit, get a big sheet, fill it out, and turn it in at the end of the seminar. So I'd also like to highlight two related seminars that are coming up next Tuesday, March 27th, from 4 to 5:30 p.m. Dr. Philip Clifford will be speaking on mentoring the next generation of biomedical scientists in the Searle Center Lecture Hall. And the following morning, Wednesday, March 28th, from 9:30 to 11:30 a.m., Dr. Clifford will be speaking on planning for a successful career in science in this room. The first lecture is appropriate for PIs who are mentoring postdocs and graduate students, and also for postdocs and graduate students who expect to need PIs someday as well. The second lecture is appropriate for postdocs and graduate students who want to set specific goals for taking charge of your own career, and hopefully that is all of you. Dr. Clifford is a nationally recognized leader in postdoc and graduate education. He was one of the creators of the FASTA Individual Development Plan, and he last week won the Distinguished Service Award from the National Postdoctoral Association. So it's a real honor to have him joining us, and I hope you will come see him speak. So again, today's topic is managing the lab, practical tips for faculty, postdocs, and graduate students. We have three speakers representing a range of lab management backgrounds, and they will be joining us on the stage in a minute, but they are from an academic school of medicine, Dr. Sally Kornbluth, Vice Dean for Basic Sciences, and James B. Duke Professor of Pharmacology and Cancer Biology in the Duke School of Medicine. Dr. Kornbluth will start things off with a presentation covering the main topics, and after that she will be joined by panelists. From industry, Dr. Deborah Bowles, Manager for Assay Development at Advanced Liquid Logic. And from an academic lab housed in an Arts and Sciences department, Dr. Mohammed Noor, Professor and Associate Chair of the Duke Department of Biology. So again, Dr. Kornbluth will start things off. Then she'll be joined by the panel, and we have some questions that were submitted in advance. Thank you for submitting those. So we'll begin with those. If there are any questions from the audience for Dr. Kornbluth, please feel free to jump in.
Well, I'm always a little bit trepidatious when I see members from my home laboratory at this presentation for two reasons. One, I don't want to give away my state secrets, but the other is that I'm worried one of them is going to stand up and say, "You don't do that, what are you talking about?" So I'll ask them to tell me that privately after the presentation. Okay, so I'm going to tell you a little bit today about my experience at Duke running a lab and some tips that I've gleaned over the 17 years of having a lab. But I should say that some of the tips I'm going to present you are not mine. They come from two books that I really recommend. One is called At the Helm by Kathy Barker, and this is, some of you may have seen her book At the Bench, which is really for people in the lab, which I highly recommend also, but At the Helm is really a lab manual, if you will, for new PIs. And then the Girls Welcome and HHMI people have this Making the Right Moves book, which I think is also really helpful when I've drawn some information from that book. Okay, so here's what I'm going to be talking about today. Basically, how do you go from this situation where you get a new job and you're looking essentially at an empty lab to having this situation where you've got a good lab with people in the lab, to this situation where you're actually publishing papers in good journals. And so we're going to look at the various elements of this process. And essentially, what you need is good projects, good people, and money, which is necessary to make the other things run. So I'm going to talk a little bit about each of these elements and what my strategy has been. Everyone has their own personal style, but I think some of these principles you can take away as general. Now, obviously, success in academia relies on research, teaching, and service. So, if you're on a tenure track, eventually when you come up for tenure, all of these things will be evaluated. Research in an institution like Duke is usually the lion's share of the evaluation, but these other things are also important. Now, one thing I'd like to say to people who are thinking of starting a lab, or to people who have new labs, is that when you think about research publications, singles count. And what I mean by this is that not every paper that you publish is going to be a Cell Science or Nature paper. And what people who tend to come into a mindset, whether they're students, postdocs, or PIs, where that's going to be the only thing that's important, are going to be destined for disappointment and possibly failure if they have that strategy. And part of the reason is that, particularly as a new PI, when you have new trainees, it is the rare trainee that can come out of the gate and do that kind of work. So the other thing in terms of research is establishing a personal reputation, because when you come up for tenure, a lot of the things are going to be, a lot of the evaluation is going to be based on letters of recommendation from colleagues, and so it's really important to get out to meetings. Obviously, publications are important. Sort of in this day and age, emails, texts, Twitter, whatever you want, electronic communication becomes really critical for supporting collaborations, etc. Having long-distance collaborations and really establishing things with people in your field are going to be important, because those are the people who are going to be evaluating you. Obviously, and I'll be talking about this, funding is critical for being evaluated positively in the research arena. It's interesting, people often ask about how important teaching is, and to be absolutely honest, I think you have to be competent at teaching in order to be evaluated well. It's preferable to be an excellent teacher. It depends on what kind of institution you're at. An institution like Duke, as I said, researchers may be more prominent, but it's important to teach competently. And the other thing I'll say is, down the road, if you're going to start a lab and you want to get tenure somewhere, keep good records and ask for student evaluation. So, I wound up in the unenviable position when I was coming up for promotion. I hadn't kept records on anything. And I had to go back through 7 years of calendars to find out, what classes had I taught, what student committees had I been on, etc. Really just looking for that sort of thing. It's much better to be a kind of meticulous record keeper out of the gate. And then, your academic service in-house or outside is going to be important. So I'm going to really be talking today about the research piece and how you manage a research lab. So the critical thing, obviously, yeah.
About the question that we have highlighted here, if someone is writing an application and you ask them a question of that, would you put that on somewhere in the letter?
Oh yeah, in terms of job applications, or even in the K-99 application, I think it's worth mentioning. But and we can get to questions at the end probably. But I think, and I'll speak to that a little bit later. But that really falls more into the realm of how you get your first funding, and we'll get to that. When you start a lab, obviously the most critical thing is really the human resources and the people that make up your research team. Now, the first thing is obviously you as a PI. So, especially these days, we're hiring, the competition is so fierce. The first obvious question is, why you? In other words, why should you be the person running this lab? Now, obviously, the main reason somebody gets hired is because of their scientific skills. They can do experiments, they can analyze data, they can write up data, but the truth of the matter is your scientific skills are only a small slice of what's going to make you ultimately successful in science. As important are confidence, resilience, integrity, communication skills, and the persistence to deal with difficult people, difficult situations, etc. I think when I first started, when I got, you get constant rejections. You get rejections on papers, you get rejections on grants, you get people who don't want to join your lab, you get people who join your lab but they want to tell you that they really don't like you, etc. And so you really have to be resilient and have, some confidence that things are gonna work out okay. Now, what do you have to do as a PI? Obviously, you have to set the scientific direction. Depending on what materials, what background you came out of from your postdoc, you're going to have a whole lot of possible avenues to go, and you have to decide what you're going to do, and we'll get into that. You have to pick the right people, you have to get money, and this is actually really important. You have to be the cheerleader, so no matter how despondent you might feel when things are rejected, etc., you sort of have to get everybody else in the lab to feel good about what they're doing and cheerlead when people get good results, etc., because if not, they're going to become despondent as well, and that kind of can lead to a bad outcome. So what about picking people for the lab? So I'll get into how you pick them. And then there's the issue, once you have them, of how you manage them. And this sounds always a little bit Machiavellian when I speak about it, but you have to get what you want. In other words, you're running a lab. The truth of the matter is, you've got to get them to publish papers. You've got to get them to get the data that you're going to need for grants. There's no question about that. But it's your responsibility, particularly if you're taking trainees, you have to guide and mentor them. So you have to give them what they need. And you know, what I found over many years of running a lab is that there is no one-size-fits-all answer to this. You're going to have to tailor your management, in essence, to individuals in the lab to get what you want from them and to give them what they need, because there's going to be a huge range of capabilities, motivations, etc. And you know, the last thing, unfortunately, is you have to learn to fire them if it doesn't work out. And I have absolutely no skill in this arena. It used to be, you know, the motto of my lab used to be, you know, full employment in the Kornbluth lab. So, you know, I shouldn't say that with people in my lab here, but you know, it is important, particularly if there's an individual in your lab who's ruining the intellectual or sort of even social atmosphere in the lab. It's really important to know when it's time to cut bait. So how do you pick the people, and what are the right people? Now, as you're starting the lab, you're going to have the possibility of getting technicians, students, postdocs, and you know, people run labs in different ways, and they have different strengths in managing different sort of categories of people. The first question will be, you know, usually when you go to a new place, you have to hire a technician, because you're going to have to do a lot of work that is not you're not going to want to do with your time, you know, from ordering all the equipment, setting up the lab, you know, unpacking the boxes, setting up all your accounts, etc. And a lot of people hire a technician up front to take care of all the business of the lab. Some people like to have technicians that actually do experiments. And my experience with that has not been very good. A lot of people do that very well, but you have to assess your strengths. So I found with technicians, I did not give them enough detail to run a credible experiment. So, you know, if I'm dealing with students or postdocs, we can talk about the concept behind the experiment. But with technicians, you know, they might, especially when they're first starting, they might want to know, you know, how many microliters to load on a gel. And I was not giving them enough detail to do experiments successfully. I did hire technicians early on to really take care of things in the lab. And when you are trying to hire one of them, you can get them by word of mouth, obviously, human resources, friends, etc. But one thing, you know, I did with my first technician, which worked out really well, was to just advertise in the local paper, especially if you're located in an area where there's a lot of biotech or pharmaceutical companies, particularly the pharmaceutical companies that are laying people off. There are a lot of people looking for jobs. It's important to get recommendation letters. One thing I will say is never get a recommendation letter for a critical hire that you don't follow up with a phone conversation, because it is amazing what people will tell you on the phone that they will not tell you in a written document. You can read between the lines sometimes that there's something wrong with the person, but you really want to find out. And I almost hired a technician straight off with glowing letters, and I called, and then at the very end of like a half-an-hour phone conversation, I think the person felt sorry for me that I was just starting the lab, and they blurted out that the person was like really bad news, you know. So, and they were writing these glowing letters to get rid of her. So, you know, you really want to get there. You'll want to know what their work experience is, what techniques they know, but often you can teach a smart person to do whatever technique you want. And the other thing is whether you're going to give a technician their own project to run, or if they're just going to be helping others or you. Are they going to be your sort of, you know, hands in the lab? Are you going to assign them to other people in the lab? Or do you really expect your technician to have some intellectual ownership of the project? And it's something you have to think about before you go down that road. Now, whoever you hire, you want to have someone who's smart, who's organized, and who's not high maintenance. Now, this may seem like a funny thing to put in, but you can have all of your time taken by people who are demanding, difficult, etc. And if you can get people who are low maintenance in your laboratory, who will function, you know, pretty calmly about things, that helps a lot. A technician particularly, they really have to have good lab hands, a strong work ethic, and be enthusiastic. Never hire anybody that you don't interview in person. Even if you're hiring someone from, you know, 3,000 miles away, 5,000 miles away, spend the money up front to fly them in. You could probably do an interview on Skype, but I have found that nothing beats interviewing someone in person, and I'd rather make a, you know, $2,500 investment for an interview than, you know, wind up having to spend, you know, $40,000 or $50,000 bringing someone in and spending a year realizing that they were the wrong fit. Now students, you know, in a place like Duke, students are often the main intellectual workforce in the lab, and you don't, particularly when you start, where you don't have a lot of postdocs, and you really have to have students that are owning projects, performing projects. And, you know, the question I often get from new PIs is how do they get students to come to their lab? You know, because there are a lot of labs for students to choose from. Now, you can send emails to new students within limits. It used to be student mailboxes, but no one checks up with their physical mailbox anymore. But you can do that, but there's sort of a statute of limitations on that, I would say. Colleagues don't like it too much if people are advertising for their lab. I think there's a really narrow window of opportunity when you first started as a PI to mail the students in the program and say, I'm a new PI, or better yet, get the program administrator to email students and say, this new PI has come, etc. After your first year or so, that tends to be frowned on. It's important to go to the beginning of your events, social events. Here we have a corporate ethics course, if people can get in on that, it's good. Never pass up any opportunity to do a departmental presentation of your work. Similarly, if you're asked for in-house seminar series, the other thing is I think it's important is to ask your colleagues to refer students your way. So when I first started, I remember, Anne-Marie Pendergast and Pat Casey all had, students falling out of the woodwork. And, I went to them and I said, if you have students that you don't have room for, can you send them my way? Because I really wanted people to rotate in my lab, and they did that. And my first 2 students were actually people that had rotated in those labs, and there just wasn't room. The other thing is you want to advertise to students the strengths of a small lab and a starting PI. How you're going to be giving them a lot of hands-on attention, how they're going to be doing the important work in the lab. Of course, now that I have a bigger lab, I advertise the excitement of a big lab and all this other stuff. So you have to be kind of adaptable. So what about, so Duke and most other peer groups, peer institutions now, students pick labs based on rotations. So they actually rotate through labs and do experiments. And there's 2 sides of the rotation, trying to get the student to want to come to your lab, and also getting to pick who you want. So, and getting to tell students that don't want to have to come. So, what I would advise is never to give a generic project. Try to showcase your system. So, early on when almost all my lab was doing Xenobus stuff, everybody did a Xenobus egg extract project. Nobody did cloning that they could do in any lab. Now that we do more tissue culture stuff, you could argue that some of the experiments I give rotation students could be done in other labs, but we still try to embed it in the intellectual area, and don't give them something generic. Make a series of deletion mutants and come back to me in 6 weeks. You also have to decide whether it's a self-contained project with your supervision. So you're going to actually work with them directly and try to get them through a part of the project, or you put them as working as a member of an appealing team. Now, again, this may depend on where you are in your career. When I first started, I was the only one who knew how to do anything, and I was giving individuals projects and really working with them. But now that I have a larger lab plus an administrative role, I always try to put people with others in the lab to help mentor them, and they'll usually do a small piece of a project that's already ongoing in the lab. One thing, though, is you need to give people a project that has some probability of getting data. No matter how great your lab is, how intellectually stimulating, if you put students on a project that they get absolutely nothing out of, they're just not going to join your lab. It's not going to happen. Now, once someone's rotated in the lab, you really have to decide whether to take them. I always find it really important to determine whether other people in the lab like them, because, and in general, when people veto taking somebody in the lab, I don't take them. They have to be intelligent and enthusiastic. And this took me a number of years to learn. Can they get a single piece of data? Now, I don't mean some earth-shattering, wonderfully positive result. I mean an interpretable piece of data. So if someone spends 6 to 8 weeks in your lab and there's nothing they produce that you can figure out what on earth it means, I can guarantee you that's going to happen for 6 years, or 7 years, or 8 years, or whatever. So it's a good idea to really, evaluate whether anything coming out of their bench is interpretable. Now, what kind of red flags are there in taking people in the lab? And I actually adapted this from that book. One is unwillingness to take responsibilities for their own actions. So if experiments don't work and they're always blaming somebody else or the equipment or the reagent or whatever, that's a bad sign. Everybody should be able to say, I did this wrong, I made this error, I didn't do whatever. The other thing is complaining about others in the lab. If they don't like other people in the lab during a rotation, they're not going to like them over the long haul. Demanding special privileges. In other words, I need to come in only from 3 to 4:30 on Mondays, Wednesdays, and Fridays because I take tango classes and whatever. So if that happens during rotation, it's a bad sign. Evasiveness. If somebody, and this goes not only for rotation students, but throughout your career, if somebody will not show you their data or they're evading you when you ask if they've done a specific experiment, that is a very bad sign and should be avoided. Memory loss about experiments. I always worry when I remember somebody's experiments in much more excruciating detail than they do. If they can't remember what they did or why they did it, bad sign. High absenteeism, obviously. If they're not ever in the lab, particularly during a rotation, they're not going to be in the lab later either. Now, occasionally, or if you have a lab that gets a lot of rotation students, maybe more frequently, you're going to have to turn down people who want to join your lab. And from Barker's book, I think this is good. The advice that people gave me that is incredibly true but incredibly hard to follow is to not hire people when you first start out. It is such a strong impulse. You have this empty lab and you just want to fill it up so it looks busy. But you often get people who are really bad. It's hard to apply the kind of criteria you should in the beginning with people. It is much better to have nobody in the lab than to have bad people. You're much better, standing at the bench doing the experiments yourself. So you might turn down people for different reasons. One is, just they're incompetent. One is you already have too many people. You have to assess whether you have the bandwidth to really be able to mentor that person appropriately. As I said, people might not like them, or it might be a bad fit with the needs for supervision or your time. So sometimes, I started off with a student who, one of my first students that really required a lot of hands-on training. She just didn't have the background, she just she didn't have the skills in place, but she was very, very talented. And by the time she graduated from the lab, she had like 6 papers, and now she's a faculty member at a prominent research institution. It was interesting because another large lab at Duke did not take her because they thought that she would require too much hand-holding. I was a first-year PI. I didn't mind doing the hand-holding, and years later, the other PI was like, oh, I regret so much not taking her. She turned out to be such a superstar. But it's not clear to me she would have been a superstar in a setting where she didn't get a lot of personal attention. You also might not have a suitable project for a beginner. So for instance, let's say you're doing very intricate, animal neurosurgery, for instance, where you have to, really have great technical skills. Unless you're going to accept that there's going to be a very long learning period or learning time, you may not have a project that's suitable for a real beginner. Now, what about postdocs? When you first start out, it's very tough. Usually the postdocs you get when you first start are either geographically restricted. In other words, they might have a spouse or some other family issue here or whatever your institution is, where they really have to find something in the area. I say this because, if you go to a very big institution and you're one of several people who does what you do, and there's a real famous person doing the same sort of work, most postdocs who want to get a big academic career will tend to gravitate toward the person who's more well-known. And when you're first starting, you really have to make a good case for a postdoc that you're going to be able to get them a job. In terms of thinking about postdocs, I always ask if postdocs are better than the students we can get. We get very strong students here at Duke. If I'm going to have to train a postdoc as if they were a student, I'd rather take a student. What is their background? Techniques? How smart are they? I always place a lot in their seminar and the interviews. So, we always try to ask sort of pointed and rigorous questions at their seminar. And if they can't answer sophisticated questions, particularly if you can come up with questions from outside the field they're in that are more sophisticated than something that they've considered, that's always a red flag. Again, recommendation letters, phone calls. You have to consider if you're going to like having them around the lab for 3 or 4 years. But remember that they need different things from a student. So postdocs, particularly if they want to go on in academia, are really focused not only on getting training and getting papers, but they want to know what projects they can bring with them from the lab. They want to know, what you're going to do to help them get a job. They're going to want to have some degree of independence. And this can be actually thorny, particularly when you have a postdoc who's working on something very near and dear to your heart, or who's working on a name of one of your R1s. You have to think about how you're going to carve off things for a postdoc, and if you're not willing to do that, don't take postdocs. The other thing, though, is, of course, is with a postdoc, they bring a lot more independence, and they can actually help supervise other people in the lab effectively. So those are the sort of things you have to weigh. And often a postdoc can get their own independent funding. And so that's also a variable to consider. Students, there are student fellowships available, but they're certainly not as plentiful as postdoc fellowships. Now, what about mentoring? If you take students and postdocs in your lab as I said, there are things you need from them, but it is your responsibility to make sure that they are well trained, that they get what they need. And again, from the HHMI book, scientific mentoring is a personal one-on-one relationship between a more experienced scientist and a junior scientist or a scientist in the making. The mentor is exposed to the trainee's energies and ideas, and the trainee receives the guidance and encouragement necessary for professional development. So that is really the contract that you enter into when you take someone in your laboratory. And you have to think in terms of your mentoring style, what you're going to do. So how accessible are you going to be? Are you going to have an open door policy where people can wander in and out whenever they want? Or are you going to have scheduled meetings? Or are you going to have a combination of the two? You have to really be kind of open-minded. You're going to get all kinds of people from all sorts of backgrounds. It's important in mentoring to try to be consistent. I think probably the most unsettling thing for somebody in the lab is, if you're super friendly to them one day and you're, hostile to them another day, it really leaves people, there have been animal experiments like this too. That's the best way to create fear. So it's not a good idea to be inconsistent with people. You really have to try to be consistent on an individual basis. You really have to be patient. Not everybody progresses at the same speed. Honesty is critical in both directions. I think, that is the best reason to fire somebody if you feel that they're lying to you, but you have to be honest in the other direction. And once that relationship of trust breaks down, everything's completely over as far as I'm concerned, because then you won't trust their data, you won't trust what they're telling you about experiments, what's gone on in the lab, etc. People come to your lab because of your savvy. You have to be smart. So a student or a postdoc might come to you and say, we're submitting this paper, what do we put in the cover letter? Who should we ask for reviewers? When you go to a meeting, what should you put in a poster? Who should you talk to? What postdocs should you apply for if you're a student, et cetera, et cetera, et cetera. Students are coming to you, or postdocs are coming to you because you are supposed to have some specialized knowledge that they don't have. And so you really have to have a little bit of savvy, and you also have to be discreet. So this one's really hard, especially if you're kind of, a talker, as I am, which is people are going to tell you personal things or problems they're having, and you have to keep it to yourself because you can really undo someone if you communicate their personal information. And I think this was really smart in this book, which is one of the lessons is that my job is not to be their best friend. My job is to be their mentor, and my job is to be their boss or supervisor. I had this sort of egalitarian thing where I was trying to run a professional laboratory, but I was also wanting to be buddies with everybody. I've come to realize the alternative, to have a little distance. Things work better if it's clear that I am the head of the lab. This is incredibly critical, and especially when you're first starting and you may not be that different in age from the people who are coming to your lab. In fact, you may have someone in your lab that's older than you are. And it becomes critical to really, you want to be friendly with the people in your lab, but it has to be very clear who is the authority figure. And I think, and I'll get to this a little bit later, part of the critical issue here is not to talk about people in the lab to other people in the lab. You come out of a postdoc when you're just one of the people in the lab, and you're used to gossiping, and you're used to talking to your buddy at the next bench and saying how the person, that bench is like such a loser, and whatever. You cannot do that as a PI. I can guarantee you, if you tell somebody in the lab that somebody's a loser, it's going to get back to them. The only issue, though, and I sometimes walk this fine line myself, sometimes there's somebody in the lab that's having trouble, and the best way to help them is to enlist the participation and help of other people in the lab. And you really have to play that carefully. You have to sometimes you have to take people into your trust, but it's not just for the purpose of gossiping, it's usually for the purpose of something constructive. And I do that on occasion, and sometimes it's important because a student or postdoc can often hear advice from their peers in a way that they're not going to hear from their mentor. So that's a fine line that you have to balance. You have to motivate people. And this can, as I said, could be a little Machiavellian, and you have to ask yourself, am I going to use the stick or the carrot? So, am I going to be like very demanding and harsh, or I'm going to say, no, if you do this, we're going to get this great paper, and you're going to get this great job, blah, blah, blah. Or, is it like, we're partners, we're all in this together and we're all pulling in the right direction. Now, to some extent, and again, I'll get to this later, we're all limited by our own personalities. You're not going to become somebody that you're not, but you have to think about how you will motivate people. Now, invariably, at least one project in your lab at a time is going to be going badly. Hopefully it's not your only project. And you have to ask yourself, is it the project? Sometimes you really give someone a dog of a project that's really, really hard to do, and you have to recognize that you've given them a terrible project, put them on something else. Is it a personal problem? Sometimes somebody has, things going on in their personal life, a parent who's very ill, or a child who has a problem, or whatever, and it's important to get to the bottom of that, because it may have nothing to do with their science. Sometimes it's a bad match between the project and the person. And I think back on this around my, 4th or 5th year here. I was trying to do a project, and 4 or 5 people in the lab had tried it and got nowhere. Then a guy came in who was a very skilled experimentalist, and he got 3 envelope papers out of that project. But it just took the right person who was willing to try 50 different things to get it to work. And he did a really good job, but it was a bad match in some of the other cases. And then you have to consider, you tend to want to blame the person who's doing the project, but sometimes it's just your fault. You haven't given them a good project, you haven't managed it well, you don't suggest good experiments to them, you've sent them off on a wild goose chase, and sometimes that's pretty hard to come to, a decision to come to, especially when it's one of your favorite hypotheses. It's worth bearing in mind. So how do you actually manage a group, particularly a large group? I think almost all labs have regular lab meetings. I think that that's critical for people to get up and present their work regularly. It teaches them how to present. It teaches them to get critical feedback. People in my lab here know that we sometimes struggle with getting everybody in the lab to ask questions and give critical input, but I think that's important. Small group meetings may be a subset of the people working on an individual project. That gives you the opportunity to really, really drill down. It also, I find, now I have an administrative role and I'm not in the lab all the time, but even when I was in the lab all the time, I had scheduled meetings because people vary in their willingness to come in and out of your office or to stop in the middle of something and talk to you as you're wandering through the lab. And so by people knowing that they have a certain time, every other week, let's say, that helps. That gives them, particularly sort of a more introverted person, the opportunity to present their data and discuss their data with you in depth, and they know that time comes. Obviously, you want to sometimes have individual meetings or pep talks. I think it's not a bad idea once every 6 months to have people do a written 1-page bullet, what they've done in the last 6 months and what they plan to do in the next 6 months, and then meet and discuss it with them. The reason for this is twofold. It helps people think about what they're planning to do. It also, frankly, sometimes people will come in and realize they haven't done anything in the last 6 months, and that's a good tool for them to think about it. I always like people to lay out their figures or outline papers, and it's interesting, I think people do this at different stages. I like to do that very, very early, when we're just even starting to kind of mature into a paper. Even if there's a lot of blanks, like we have to do this experiment, we have to do this experiment, I find that it really crafts which direction the paper's going in and which experiments you have to do. Now, obviously, sometimes it turns out differently, and you have to recalibrate, but it's nice for people, once they've got a series of significant results, to really be thinking in terms of how it's going to be a paper. That stops people from going down all kinds of tributaries that are not going to contribute to publication. Sometimes people have larger strategizing sessions, and then there's open door time. I had my graduate advisor was a very quiet man who used to come into work in a very big lab, and everybody got along well, and everybody really liked him, but he was very shy, and he used to come work late at night. So the whole lab shifted so that people would work from like 11 or noon until like 10 at night or 11 at night or midnight or whatever, if they wanted to interact with him. But he used to actually just stroll around the lab. So he'd stroll through and stroll through and stroll through. And then, about his 15th time around your bench, you'd finally spit out what you wanted to like show him. So his management style was to just like eventually kind of coax people to say something by just sort of being there all the time. Eventually be, okay, I did the experiment. So, and it worked for him, but he would never confront somebody directly. So one thing that's often very difficult in the lab is to deal with territoriality and to establish the territories. And I have to say, it is very different from the other side of the desk. When you're the PI, you feel like all the projects are yours, and who cares which person's doing it? The people in the lab really care a lot who's doing it. And I remember, when I was a student, the same advisor, I told him a cool idea I had, and he didn't do this willfully, it just happened. He integrated it into his thought process and suggested it to one of my colleagues who did the experiments, And so you have to really kind of think about whose ideas are things. and how you move things along. Now, the thing about that is, and I don't remember about the slide on this or not coming up, but people can stake their territories and do nothing about it. So I think as a PI, you have to stop people from parking on projects. There are people who think that like every project in the lab is theirs and nobody can work on X, Y, or Z. That's fine if they're going to actually do the project, but if they're not, you have to discourage people from putting a rope around something and not letting anybody else work on it. Now, it's important, obviously, for you to discuss with people, but it's very important to encourage discussions between lab mates very early on as to whose project is whose, what you're working on, etc. I thought this was good. Bob Weinberg, actually, is a big cancer biologist up at MIT. Natalie Anger, who's a journalist, actually spent quite a long time in Bob's lab trailing around after him. And there's a book called Natural Obsessions, which is, it's an entertaining read. It's like reading a novel about your own life if you work in a lab. And basically what Bob said to her was, I must spend 60% of my time trying to maintain a sense of harmony in the lab. I want people to get along, to cooperate. It's very difficult to do that, It's hard enough to do with your own family, but managing with 20 people is almost impossible. But really, that's what my job is all about. So people come to me with personal, they don't get along with so-and-so and things aren't working. And, internally you go, oh no, but you have to deal with it. Now, all that said, you set the tone. You're stuck with your own personality. For me, it's not going to work to just walk back into the lab silently. Like, I can't do that, It just depends on your own personality. And what I have found very frequently is you can take people from all different backgrounds. They tend to acquire the personality of the PI, and what I mean by that is how they treat people in the lab is going to be mirroring how you treat people in the lab. So even though we had 25 people or something in the lab when I was a graduate student, and it was not a collection of people that were destined to necessarily get along, it was a very tight group because the PI made it clear that nonsense wouldn't be tolerated. He was going to be nice and calm, and everybody else was expected. And if he saw some drama going on, you would be embarrassed for him to see that. He would turn on his heels and walk out of the room, and you would know that, you've done something bad. So, I think you have to manage with your own personality, but realize it's going to have an impact. Now, one thing that's really important is lab morale. It's interesting. I tend to see that the lab is up, the lab is down. It's almost like everybody's experiments are working, nobody's experiments are working. That's something that you have to learn to tolerate. But what you really don't want is schadenfreude, and this is pleasure in the pain or failure of others. You don't want the person here to be really happy that somebody else's project isn't working. And I have seen that in labs over and over. If people are not being super successful, they really don't want anybody else to be super successful. They want everyone to be sort of equal. You've got to get people in the lab to take pleasure in the scientific accomplishments of others in the lab, and also realize, one, their turn will come, and two, everything that floats the boat is good for them. It's going to help funding in the lab, it's going to help attract other good people in the lab, but that's tough. And that's what I call, result jealousy. You're going to get, someone's going to get a spectacular result, and it is hard for other people in the lab whose projects are not working to see that. So you have to be even-handed. So you have to be, a sort of stone, statue, not to react excitedly if someone comes up with a spectacular result. But you have to not make it seem like that is the only important thing going on. The other thing is everybody has his or her day in the limelight. So I remember this very clearly. I had a student in the lab who told a postdoc in the lab that I never pay any attention to him and that I'm not interested in his project. And I said, oh, just wait, his time will come. And, several years later, so he wound up having 8 papers in my lab, including two cell papers, okay? And so he did really well. We got along great. But I remember saying to him, you thought I'd never pay attention to you. Now you wish I would stop paying attention to you. Because I was like on him every day. What's the next thing? You're getting stuff. So people fall on different ends of the spectrum depending on where their projects are. I think it's important to maximize collaborations within your group. Not everybody wants to work with someone else. Sometimes they like to work alone. But this can be very effective. And I have to say, in this age of co-equal first authorships, which did not exist when I was a student, it makes things a lot easier because different people who collaborate can actually get co-equal credit for the collaboration. It's important in a lab to have socializing, have small talk, people will have their lunch together or parties. But what's really important is your own emotions, to control your anger. I think I've really yelled at somebody in the lab only a handful of times over 17 years, and it's really only once that I can think of that it was because I totally lost it. And I was provoked. But anyway, but I think this is really true. PI said, I lost 2 years in the lab because of one incident where I lost my temper publicly. A student, not from the lab, told all the other students about the incident, and not one person even did a rotation with me for another couple of years. I've seen this over and over. It is very easy to ruin your reputation as a PI by, screaming at students or treating them badly. Same with postdocs. So it's important. You're going to get mad. The other thing is you can fire off emails to people very easily. I would very, very much advise if you're mad and you write an email, don't put an address in the send thing and save it as a draft till the next day, because your words have a much bigger impact than a word from a colleague. So if you say something negative to someone, even if it's something slight, they're going to be really upset about it and tortured about it. And I've had, a student or a postdoc come to me and apologize about something that they did 3 or 4 days later that made me mad, and I would have no recollection about it, or if I had been annoyed about it, it would pass in 5 minutes, and they would have spent, several days kind of, ruminating about it. And I've done it myself when I was a student and postdoc. You worry about what your advisor thinks, and from the advisor perspective, you should be aware of the fact that the people in the lab are going to be worried about what you think. I mentioned no talking about a member of the lab to another member. Don't attack people personally. So even if you think that the reason someone's work is going poorly is, they're incompetent, they don't care, you have to frame it that it's not about them. It's about how they address their work. And as I said, never send an email when you're angry. It's very important to set the intellectual tone of the lab. This actually is a quote from me in this book. I hated journal clubs when I was a student and a postdoc, and I vowed never to have them when I had my own lab. I hated them. I still hate them. Some people really, really like them, and I have no problem if people in my lab want to get together and discuss papers. To me, a journal club where people presented individual figures was not a good way to go through a paper. People want to all read it and have a high-level discussion, great. I just never liked it. And there are other ways to have a high intellectual tone, though. Ethics is absolutely critical. You're going to have so many pressures. You have to balance between pressures and high standards and be clear where you stand. It is so easy to convey to trainees that you want a particular result. I find myself doing it all the time. Oh, we get this, and then we get this, and then we get this, we can do this. You have to make it clear to people in the lab that what you're saying is not get this result. You're saying, this is a cool idea and what I hope will happen. And I've had occasion for somebody in the lab to say to me, oh, I'm really sorry I didn't get this result, I got this result. And I'm like, don't apologize. I mean, it is what it is, but it's very hard to do that. The other thing is work ethic expectations. PI's hours can set the tone, particularly at the very beginning. I find, my stance on it has always been, I don't care when you're in the lab, as long as you are producing and get things done and you put in a reasonable amount of time. But some people like for everybody to be there when they're there. Some people give people flex hours. I think it's critical to realize that trainees and PIs need vacations where they will burn out, and it's important to have social times in the lab. This comes up all the time with trainees when you think about who to hire. Can hard work compensate for raw talent? I don't know the answer to that. Sometimes it's yes, if it's a labor-intensive project that requires screening through things, etc. But sometimes having really good hands and a really keen intellect make a huge difference. Bob Lefkowitz often says in his talks, when he interviews people, he asks them if they're lucky. And if the answer is yes, it makes them want to take them, because luck doesn't just happen out of the blue in science. It's somebody being lucky, meaning they've done well, often means they have the talent and the work ethic. Do I have 2 more minutes, or am I out? One thing I want to mention is notebooks. So lab notebooks, and we're actually thinking about introducing a lab notebook session into the Beaufort course, because it's become clear when you start looking at the notebooks of your trainees that people are all over the map on what they consider adequate documentation. We're also thinking institutionally about whether we should be offering electronic lab notebooks, etc. As you're going through, showing people how you want them to keep notebooks is critical. Another thing, though, I think is important. People will often come with data that's already been massaged into PowerPoint presentations or cropped images or what have you. I think it's really, really important at some point that you look at their raw data. A practice that I've started in the lab just for the last 2 papers, so I can't say it's been going on for years, is I want to see in a notebook before a paper is submitted all of the data that underlies the conclusions of that paper annotated. And this came from an experience I had a number of years ago where a paper we submitted as it was going to press, the editors contacted me and said, we want to see all your raw data, because there was a Photoshop problem. It turned out to be innocuous, but they wanted all the data right away. And it was a very, very organized student who was able to send the data by FedEx within an hour of the request. I can tell you that not everybody in the lab can do that. And so, you really need to think about seeing all the raw data and making sure that people can get their hands on the raw data. The other thing is, very frequently you're going to find people who show you, 50 experiments, and together they're going to make a very nice paper in terms of their conclusions, but not a single one of the experiments is of publication quality. So you have to really start early convincing people that they have to repeat an experiment until it will convince not just you, but people in the outside world. Labs differ. A lot of labs have lab jobs where, somebody has to clean the tissue culture room, somebody has to, make the SDS buffer. You can decide, how much cooperativity and collaboration you want to have in the lab, and then assign people lab jobs. Now, that tends to make things very convenient for everyone if there's, a particular buffer that is always there. The only danger I would bear in mind is that when one of those solutions is made badly for some reason, all the experiments in the lab tend to come to a halt. So when everyone's experiments stop working at the same time, you might take a look at all the common reagents. So this is my advisor. He actually passed away a couple years ago. But he had this great lab manual that everybody was given. In fact, when we all met for his memorial service, everyone was reminiscing about this lab manual. It was amazing. So it had, everything you needed for a new lab member. ID badges, getting keys, computer passwords. Although at the time I have to say this was a mainframe computer. But anyway, it had everything you needed. It had all the lab policies, all the lab jobs, all the common area rules, what it was expected in the notebook, safety numbers, supplies that were available, when the lab meetings were, when the little group meetings were, common lab protocols, recipes, publications, institutional rules and policies, and then harassment policies, etc. This was an amazing thing, and I wish I still had the whole thing, but he had things like a picture of a rack of epidural tubes, and it would say, every time you do a pipette sample, move it over one to the right. So imagine you get a phone call in the middle of an experiment. You'll know where you are. I actually wrote that, imagine it. So, everything was, and it set everybody in the lab. In the lab said, whenever I pipette, I always move the tube over one after I pipette. So, he really spent a lot of time thinking about this, and it's a great thing. When I first started, I did have a lab manual of all the common lab recipes and everything, but within a few years that it just exploded and that we didn't keep it up. Very important, usually scientifically, to have collaborations. I would say that all collaborations need to be okay by the PI, but students and postdocs often forge the greatest collaborations. Just make it clear in the lab you want to know about them. There's nothing as embarrassing as having another PI come up and say, oh, those data look great. And you're like, I have no idea what you're talking about. So let your lab members negotiate the deals if possible. Generally, you want to leave authorship flexible, but it's best when 2 labs really need each other, where there's one main lab and another lab is providing supporting material. When it's 2 half stories and you put them together, those, I have to say, my most unpleasant authorship disputes have been those kind of things where I think my person should be the first author and they think their person should be the first author. Again, co-equal first authorships have solved some of this, but it still can be very contentious. You should have a policy for outside meetings, whether you want to be open or secret. This is very sensitive. You want to tell people in general, I think, they can reveal their own work, but don't reveal other people in the lab work without permission. You don't want somebody in the lab going and giving all the details of another postdoc's work and having that person be scooped because someone felt very comfortable about being open about somebody else's data. I think that's important. As you think about the scientific direction of the lab, you have to think about things like, can you shout when I'm out of time, because I'm not sure what time. Okay, what time do I need to end by?
3 slides.
3 slides, okay.
So, I have to pick. So you have to think about the scientific direction of your lab. Do you want a single project or many projects? I think it's obviously best to not put all your eggs in one basket, but you can also get spread too thinly depending upon the size of your lab. Do you want people working alone, or do you want them working together in groups? You know, it's good to have a combination of low-hanging fruit, things that you're going to get that are going to be in, you know, good, solid journals versus high-risk things. Do you want to go it alone or be a collaborator? I found that, particularly now that things have gotten so complicated, I think when I came up for tenure, actually, every single paper I published had some collaborator on it. It's important to have senior author papers when you come up for tenure, but if you have outside collaborators, that's fine, and it can often be critical. Do you want to be mainstream or unique niche? This is interesting because if you're in the mainstream in a very popular field, it can be very easy to get scooped, and that can be very discouraging. I remember I got scooped within my first 3 months in the lab in a science paper, and I just was like, oh great, now what am I going to do? And so you need to think, and you know, it helped us change directions for things that could be more unique. The thing is, if you're in too unique a niche, it can be so obscure that no journal actually wants to publish it. So you have to think, and nobody wants to come work with you. So you have to think, the best thing I think is to have a unique niche in a fairly popular field. Again, you have to know your own style. You have to know what your personnel can do. You have to make as many, I would say to make as many of your reagents as you can. We've come into a situation where we have a collaborator that's been on many of our papers for unique antibodies he's generated. We could have made those antibodies years ago, and I always feel like I'm begging for another 10 microliters, you know, so it's better to do it by yourself. I think it has to be, you have to be publication driven. That is just the reality. In this age of tight funding, it's tempting to be driven by requests for proposals or requests for funding. You see something, oh, I'll write a proposal on that. See something else, I'll write a proposal on that. First of all, it can take a lot of energy learning all these different fields, and you're just not going to have the requisite preliminary data. Now, that's not to say if you have something that fits well with an RFA, or it's some crazy idea RFA where thinking about something might get you some money, you shouldn't do it, but you should be strategic. Again, you have to think about whether it has to be your projects or choice of projects by lab members, how much is okay. There's a balance between getting the experiments done for your grants or what you want to do versus having new, fresh ideas. One of the major projects in my lab on exit for mitosis started because a graduate student wanted to work on it, and she recruited 2 other students to work on it, and it grew into a whole line of investigation in the lab. So, let's see, I've only got 2 more slides more, so I'm good. So, I give you an extra slide. So you have to think in terms of publication. I always like this journal, Irreproducible Results, where they showed you how to use the same micrograph for every paper. But anyway, don't do that. You have to think about how high you don't want to get scooped, and if you try to get everything into Nature or Science or Cell, you can ask for trouble because it can take forever and it might not get in. And you have to have a tolerance for rejection if you're going to take that strategy. So, papers are better than grants in that way. You can only send a grant to a single study section. If you get a paper rejected, you can just keep trickling down the journal and cascade. But you have to have time, not get scooped, and also get used to being rejected. You can't, co-submit to more than one journal at a time. You have to think whether you want a least publishable unit or a big story. Sometimes people wait so long that it's impossible to get their trainees graduated. The story's huge. They've had no publications for 6 years. You have to really think about whether you want to get the small piece out or a larger piece. When are you ready to write? And also who writes. There are PIs who write every paper in their lab. There are PIs who have trainees write every paper, and that's that. And then there's a lot of people who do back and forth. I tend to ask trainees to draft things, and then I frequently, rewrite it, and then we discuss, what the rewriting points are. And then finally, you have to get money. I have to say, my first year, I wrote 30 grants. A lot of them were to really little, tiny agencies. I didn't write 30 NIH grants. But that's sort of the saturation bombing strategy. There are a lot of funding opportunities that are open to you as a starting PI that are not open to you later. You might as well take advantage when you first start. There's obviously NIH is the big one, but DOD, NSF, there are lots of private sources. There are also very obscure private sources. Those are getting harder and harder to find as people get more, intense about finding money, but sometimes you'll find a small foundation that's less competitive, that really fits what you're doing. As I said, there's lots of things for starting PIs. A lot of times they're in-house grants, which, for instance, our Cancer Institute often offers pilot funding. Those tend to be easier to get, they're not as competitive, they tend to be shorter, they're smaller amounts of money, but it can really be enough to get the preliminary data to launch you into a larger grant. I can't emphasize this enough. Get advice and critical input when you're writing. You have got to have other people read your grants, which means you've got to get grants done early enough that people can read your grants, give you critical input that you can incorporate. The institution now has a lot of these things. We have, a grant writing workshop for junior investigators. Mark Dewhurst running this thing about critiquing people's specific aims and grants. In our department, the chair has started sending our grants out for some external review if we get it to him early enough. This is really, really important, and I think people often are rushing up until the last nanosecond with a deadline, and they don't have time for the input, and it's really critical. Okay, and then there's the issue of time management, and I obviously don't have to do that, so.
Okay, and now Sally will be joined by the panel. Again, our representatives are from industry, Dr. Deborah Bowles, Manager for Assay Development and Advanced Liquid Project, and Dr. Mohammed Noor, who is the Professor Associate Chair of the Duke Department of Biology, so representing your Arts and Sciences Department, rather than a School of Medicine Department. As I mentioned, some of you submitted questions in advance. Thanks for that. So we will start with those, and then we will also get to questions from the audience. So let's start with the question about time management, since you left off there. Can any of you talk about time management, particularly when you have a family?
Sure. So one of the biggest things I did, and this is actually something I only started doing a couple of years ago, but it's revolutionized my life, I think, is actually using an online calendar. I used to have one of those little day planners that your mom gives you all the time. And here, online calendar is one of them because not only do you know where you're supposed to go, but anybody else, like in your lab, knows when, okay, I'm not going to bother trying to schedule them. You get the email saying, the next student wants to schedule a committee meeting. You don't have to answer 14 different emails. No, I'm not free then. No, I'm not free then. No, I'm not free then. Maybe then, oh, the other person wasn't. You just say, here's the link, done. And they can then just identify what's good. The important thing on that, so coming back to your specific question there, is blocking off big pieces of time. So, for example, I'm a big eater, some of you know me very well. I'm a big eater, and food is very important to me, so I've blocked off every single day from 11:30 to 12:30, where nobody can schedule me for anything. And I do the same thing, sort of, the evening time, same sort of thing. I do the same thing with respect to my kids. Like, here's my kids' softball games. Gone. That's little tidbits.
Yeah, I think, allocating precise times to do things really helps. I think, as I said, meeting with some people in the lab at a certain time, I think can really make sure that you get to them. I often I don't have that many big blocks of time every day, but I designate early in the week what's going to be in those times, like I'm going to work on this paper or this grant, and then also building in a little bit of time for emergencies, things come up. I think it's very hard with balancing family, not to let your work bleed over, and you have to be a little bit careful. Like I remember my daughter saying, I'm always like emailing at night or whatever, and she was like, you're not listening to me at all. That's your laugh when you're not listening to me. So you have to carve out time for family matters too. Also, not only because it's important for your family, but also so you don't completely burn out.
Yeah, I think I actually have a 4-year-old and a 2-year-old, and also coming from a different perspective in industry. And I think this is, to follow what you just said, I can't actually have a laugh where I'm not listening because they're usually attacking me or grabbing me or milk or something. But I think for time management for me, that having children, I was in industry before I had kids, and have had 2 children, I'm still obviously in industry. And that was an enormous shift for me in terms of the way that I did work every day. So I also used to work in DC where traffic was the main source of how much time you had during the day is to get around traffic. But basically I work 8:30 to 5 on the dot every single day. And so what that does and how that changed my way of working was that, you know, even if I had 15 more minutes of stuff to do just to finish something off, I couldn't do it because I needed to leave at 5, I needed to go get my kids. So I think it changed the way that you focus and the way that you plan experiments. Certainly, one of the big focuses in industry and my job also is deadlines. And deadlines don't change, regardless of your personal schedule. So I found that I had to try to become as efficient as possible in terms of doing things during the day and understand that that's my time limit. And, you know, if you lose going out to have lunch with people 3 times a week because you take that time to get what you need to get done in that time frame, you adjust. And it took me a little while to move from not having family and putting a lot more time into limiting my time, but not changing my expectations as to how much I could produce in that time. And that was sort of hard to get used to. But certainly,
Yeah, and I think leaving in any of these things, leaving things to the very last minute is a danger, particularly after you have kids who are doing whatever all the time. You know, nothing. And I recognize what you're saying. You know, when you're leaving, you can't leave at 5:29.99, maybe a 5:30 deadline.
And so, Debbie, you just touched a little bit on the differences, or on one of the differences between industry and academia, that you have deadlines. Are there other differences that you could highlight between an industry lab and an academic lab?
Yeah, I think it's many of the things that Sally talked about with management obviously translate into industry. So you obviously will look for the same types of characteristics in people when you're hiring people for your lab. But I think while you were talking, I was just kind of jotting down some of the key differences. One of certainly we tend to have multiple projects. Everybody has a multiple project. You do have a strict deadline. You want to be able to get to a point where you can make a recommendation on a project or a product. So maybe you don't get 100%. You don't cross that last T and dot that last I. You get 80% of the way there, so that you're pretty sure that you should change direction right now, because you don't have the luxury of taking another 3 weeks to be absolutely sure that this is going to work or not work. So I think you get up and you say, well, this maybe is the least risky path forward. You also have to consider aspects of the entire other business plan, the entire other part of the product. So, for example, this might be clear. I'm in biochemistry in our company, and that might clearly be the right way to do the assay, but that's going to make the instrument a lot more expensive and non-manufacturable. And that makes it more expensive, so you're pricing out of the market that you're going into. So you adjust the biochemistry to maybe something that's not, I mean, it still works, but it's not your first choice, or it's not the coolest way to do it, because it's the rest of it. The other thing that I think is probably a big difference is IP, or patents and intellectual property. Again, I think a TACMan assay is the best way to do this particular genotyping test. But that requires licensing of XYZ and the cost associated with, I mean, it goes down to license for a molecule or TACMan as a whole, PCR, real-time PCR, all these things add cost to what you're trying to produce, and that's maybe not a consideration, not as big of a consideration when you're in an academic lab as infringing your patents of other companies. And I think communication is another big thing. Again, just talking about, I talk daily to mechanical engineers, electrical engineers, marketing, business, MBAs, and you have to be able to communicate what your issues are clearly so they understand what the issue is. If I'm telling you, you can't do it this way because of da-da-da, if they don't understand those reasons, and if their reasons are more important, then you're again, not focused towards one particular goal. I think that's probably more, but that's like another.
Great answer. Thank you. So back to academia, who are the most cost-effective people to have in the lab when you're weighing productivity versus salary? Undergraduates, grad students, postdocs, technicians? Would you hire more than one than of the other?
At least for me, well, aside from undergraduates, I think the variance within categories greatly exceeds the variance between categories. I mean, that's at least been my experience. And I've had, so coming back to what Sally said earlier, to the context of technicians, I had a technician a while back who, in 2 years in the lab, published 3 first author papers on her own, and this was largely driven by herself. I've had amazing postdocs, I've had amazing graduate students, and I've also had some people on the other end of the spectrum in each of those categories. I think I don't think there's a one-size-fits-all on that, because largely, I think the best thing is, as Sally said, is right at first going for the technician, because this is somebody who, right off the bat, is not going to be seeking much more from you than a job. And so you can get the lab set up, and that's a good way of just getting the ball rolling right off the bat. Whereas if you try to get a graduate student day one, they are seeking much more for themselves as well in the context of, I need this training, I need a formal project, and oh, look, there's no thermal cyclics, there's no gel systems, things like that. So I would defer postdocs and graduate students a little bit and right at first emphasize the technician, but it's not so much just for output, just because it works better in terms of trying to get there.
Yeah. No, I really appreciate that. I think that's right. Undergrads, you're doing it more for them on most occasions, I think, helping them. It's the rare undergraduate until very end of their undergraduate training that can really contribute. But graduate students and postdocs, I agree, it's the individuals, it's not categories.
And how about an industry, Debbie? Are you more likely to hire a recent PhD graduate, somebody who's just finished a postdoc, a technician? Is there any?
I think it's slightly different, also very much the same in the sense that it depends on what we need them to do, and how will that person be happy doing that job. So if if we have a need for instrument validation, we're not going to hire a PhD for that, not because they're overqualified, but more because I think they'll be bored with it in 3 months. I mean, they'll be excited to get into industry and try something, but if there's not a clear path for growth, or more responsibility, or more interesting things to do, then hire the person for the job that needs to be done. And I think a lot of that is also their desire, and the person's desire to grow. Like in the lab, you want them to be happy, and people who are happy will do better work and do it more quickly. And I think everybody is ambitious and everybody wants to grow. If that position doesn't have room for that, then they encourage the position that
One surprising thing I didn't realize before is that the cost difference isn't actually that big. Right? For the technician, grad student, and postdoc. Postdocs are a little bit more, and grad students are kind of a little bit, the range there is not actually that big at all.
Questions from the audience? Yes.
I'm just wondering if you could expand a little bit on electronic notebooks. What do you think about them? Are they helping? Are they hindering? What are your thoughts there?
I'm no expert, and in fact, it matters you're here. We're sort of beta testing some electronic notebook systems. It's interesting because we had a discussion today about this actually in the Dean's office about, there are some people who really think it's a risky thing because technology changes. They much prefer paper, and then there are people who feel like it's searchable, everybody can find it. There are backups, automatic backups, etc. We're actually, as an institution, just looking now at a couple of options. I think I would have more to say about that in a few months. I know you use a kind of document system.
Sort of. I don't do actually for lab notebooks, but all our protocols, we actually put in Google Docs. So this comes back to what your advisor was doing too. It's nice because then anybody in the lab, if you want them to have access to, you just click a button, boom, they have access to all the notebooks. They're very easy to update. Anybody, even at another institution, can just immediately grant access. It's not it's lost, it's stained, it dropped out all the gels or whatever. It's all very convenient.
So do you use that for sort of discussion in the lab as well, or in other words, or is it mostly papers?
Mostly, well, it's mostly like documents on how to do that.
Mostly protocols.
Yeah, protocols.
we still also have notebooks in corporations. They are actually critically important in the sense that they go back for patent, if there's ever patent prosecution or, and again, infringement. You go back to whether you're first to file or first to invent, and the U.S. is actually changing over to first to file from first to invent. So notebooks were critically important in that you could challenge another company's patent submission by saying, well, I actually invented it first. Here are my lab notebook documents. So filling it out completely, signing the corner of anything you type in, having witnesses sign it, all that gets backed up electronically, and then notebooks are stored often in fireproof safes or offsite for that reason. But we have actually also started considering getting into electronic documentation. And one of the reasons is that our lab is a BSL-2 lab, and so we don't allow anything to exit that lab. So if you want to bring a piece of paper, this is what we're going to do, or this is the concentrations I'm going to use, that no longer needs a lab once it's gone into the lab that we're doing the packages. So we scan that, we're going to that, so the idea is to scan any papers that we need to go go out back into your regular.
I mean, one thing I will say on that, though, that as an institution we will be doing is, if something's going to be translated to human application, we're going to require certain data management systems. So we know things can change, you know, the chain of evidence, how things have been handled. But we're just starting to look at different systems.
I just wonder if you could speak to developing collaborations between industry and academia from both sides. So if someone from industry comes and says, we like to test this out in an animal model, you have an animal model, can you teach us about, confidential agreement that you sign? Who does that go to? Who signs that? What are the questions that you should ask, whether you're in industry or academia, on both sides of that, develop that, so notice you don't get hurt in which project?
So, you know, there are a whole different variety of flavors of those kind of collaborations. There are, you know, straight scientific collaborations where you're both just interested in things and you're seeing how things develop. There are a lot of times industry will come, as you say, you know, want a particular assay done, and that's more of a contract. They're asking for a particular deliverable. We have a contracts office that's run by Gil Smith, who you would go to under those circumstances because you want everything drawn up. They will refer you to legal folks, you know, you have to have a confidentiality agreement, et cetera. We're actually starting to talk more with pharmaceutical companies now about services in kind, where, you know, you might want them to run a drug screen for you or do whatever. Under those circumstances, it's going to also involve the Office of Licensing and Ventures to figure out, you know, who owns the IP if something comes up from a screen, et cetera. So that's a fairly sort of complicated question with a lot of nuances, but I would say that the Office of Licensing and Ventures and the contracts folks under Gil Smith would be the first, which is OCRC contract or something. Those are the two places that you would stop first here.
And one thing to watch out for is conflicts of interest too. So we had one little partnership with a company here in the state, and we submitted a paper after that that just mentioned that the product associated with this company. And the journal initially rejected the paper, saying that it was a conflict of interest because we would take a profit associated with the production of this product. But in fact, actually, we weren't. So we had to get a letter from the company swearing up and down that we paid no profit whatsoever from it. So it's the kind of thing to watch out for.
Yeah, I would add that there's a lot of upfront work, contracts, and compensation, and confidentiality that goes on before the collaboration actually happens in the industry and academia. And we've been involved in two different types of collaboration. One where we basically developing a product and use the collaboration to learn from expertise in the field. The collaborators provided expertise in terms of if this is the target you want to go for, if this is the market you want to be in. And then we've also done collaborations where we have shared our technology with academic labs that want to use. So we have chips, and we've helped streamline the labs to do that work also. So I think they will work. We also got more basic research from them in terms of we have people in-house. So it can be mutual, it can certainly be, it is always mutually beneficial for both parties. But it can depend on who's giving it. It can also, you can get those cases where one is giving the other.
I have a question here that I want to get to. It's more on the human resources side. Sally, you mentioned that you need to fire unproductive workers if they're dragging the lab down. But do you have any tips for how to fire unproductive?
So there's different arenas. I have not actually fired someone, but I have had occasion, probably 3 different occasions, to encourage students to leave because it was not the right career for them. And in those occasions, I think it's important to, it doesn't always work, but it's important to try to bring the person to the conclusion. So, you know, Friday afternoon, you're having a conversation with them, you say, are you really sure this is the right fit for you? Are you going to be happy doing this? You know, go home over the weekend and think about it. I'm not kicking you out of the lab, but come back and talk to me on Monday. And, you know, in the 3 occasions I've had, they've all come back and been like, thank you. I mean, usually, like, when
you know, you're really unhappy with somebody, they're generally also very unhappy, and so broaching that conversation, I think, is important. You know, if you really have somebody who's dragging the lab down, you can, you know, if it's a staff person, you know, there are obviously HR processes to go through and documentation, et cetera, and working with HR. But if it's a trainee, it's a lot more flexible. And you generally, I think, have to just really be frank with the person that's not working out. And sometimes it's not working out with you, and you can still help them to find another position because it's just not a good fit.
I agree with everything Sally said. And I have actually fired a few people, and yeah, you do have to, for staff things, to go through all the HR procedures, whether the documentation of each step along the way, and things like that. One thing actually coming back to something Sally said in a presentation about rotations, that if you have somebody rotate in your lab and you're not that thrilled with them, one thing a lot of new guys do is they sort of wuss out and they just say, well, I think the lab's kind of full. The problem with that is they then go tell all their friends, oh, I was thinking about rotating with, you know, Professor so-and-so. Oh, I heard their lab's full. Oh, okay, well, I won't go there. So, so be careful with that sort of thing, because I've seen that backfire on people many times. So, you know, tell them, sorry, I don't think it's a good fit or something along those lines.
Yeah, and I think we obviously have just staff, so we do have processes where if there's an issue, so there are certainly areas that are made clear to you when you start a company that if you do any one of these things, it is bound for immediate termination. But we do, most of the cases that I've been involved with, where people have been let go, there are multiple meetings that happen before they are actually fired. And so everybody really is aware that there's a problem, including the person who is to be fired. And if you're not communicating or you're not performing up to the job that you're in, then you're made aware of that well ahead of time. And I think often you can, again, I'm sure like in a lab and switching to different projects, you can often move people within your group, or you can move people to a different department if there's just personality complex that you just can't get over, or they just are not capable of doing the job that they were hired to do. There's often space within your company for them to contribute in another way. However, and I think I said this last time I was here at this panel, when you are let go, you are immediately escorted out of the building in general. And that is usually because it is not, you are not happy about being let go. And again, it's protecting confidential information and company trade secrets, company property. So it is, although you are given plenty of warning beforehand, you are very, at any level of the company, including vice presidents, are escorted out of the building immediately.
Yes.
So in that situation, or not that situation, if there's a gulf between their perception of what's happening and what is happening, which is all your perception of it too, how do you bridge that? Like you mentioned that you try to get them to see that there's something not appealing there. Is that the way to go?
I think you have to be very concrete then and say, okay, here are the goals here are the things that I would want to see in the next 3 months, let's say. And we're going to meet, you know, next week. I want you to go home and think about what you think you need to accomplish in the next, you know, period of time, and then we're going to meet periodically. And then, if you know, and say, look, if it's 3 months or 6 months from now, we're still in the same place, you know, we really have to revisit it. I mean, there are occasions where somebody's really disruptive in the lab or doesn't get along with people, but in general, the reason that you're going to want someone to go is because they're completely non-productive. And so having very concrete goals for productivity tends to be a more objective way, where if you agree with the person that these are the goals, they can't come back and say later, what do you mean I did all this? Because it's like you've agreed what the goals are. Now, and obviously you can't always guarantee results from an experiment, but you can, people can document what efforts they've made, what approaches they, you know, what they've tried, and if they haven't tried anything, or they just kept doing the same thing over and over again, you know, that's something that'll get teased out with that kind of formal sort of documentation.
One very important thing with as I was saying too, is do it first in person, but then follow up in writing, because people are not going to remember. So that's the most important part. The second is if it's a staff person, that's the documentation you're going to need to have too. This shows the date that it was done. Here's the exact things. But more important, usually that doesn't come that. It's more important just because of selective memory. Oh, I didn't think you really meant that. I thought, no, there it is.
I mean, this is important from the trainee's perspective too. Sometimes you might have a contentious interaction either with someone in the lab or with your advisor, and if you have a conversation where you think everything's settled, go back to your computer and say, here's what I understood from our conversation. That just, then someone will say, no, that's not what we're talking about. So I think it's good to do that up front.
Any other questions?
How much do you feel like it actually works to cater to students' individual work styles as far as some students work better if they're micromanaged a little bit more and other people want to be able to work flexibly and independently? I feel as though PIs that I work for have adopted one style of the lab and then that's successful for some students and not for others, but then they feel as though if they give different expectations for different people, it's a little bit unfair in the lab. So how do you feel like you best do that?
Well, variance isn't even just with emotions, but even for a particular person. Somebody coming into the lab, what they're going to need, say their first year, their second year is not going to be at all what they're going to need or want in their last year. So at some level, I mean, you as a PI have to cater because you can't, there's no one size fits all even for an individual. So it's tricky.
I think, the most effective thing is to be able to cater and really tailor to each individual. Now, again, you're within the limits of what you can do. So if somebody wants to come to my lab and expect to be micromanaged by me now, it's not possible. Like I just can't, I don't know what gel somebody's running like in a day, which I did know at the beginning. So I think there's a limit to what you can do, but I think if you can give somebody independence who really wants it and needs it, and they can live up to that expectation, it's great. I think people in the lab have to realize that, as you're saying, different stages, they're going to need different things.
Yeah, I think the same holds culture for industry. I couldn't agree with Sally more that you and Mohammed that tailoring to each individual person in your group and what their strengths are will make them so much more productive and happier and good. And I think people who have a preference for more hands-off or more independence don't care at all that you're spending more time with something else because they don't want that. They don't want that part of your time. You give them something else. So I couldn't agree more that tailoring is the way to get the most productive and happiest students.
As PIs, generally, how many percentage of your time are spent on writing grants and how much time on interacting with my mentees, how much time on administrative activities, student society?
Yeah, that's fine. I mean, I have a 50% administrative job, so that's my story. And no, seriously. So I spend 50% on administration, and then everything else kind of blurs together because I feel like you're always writing grants and you're always writing papers and you're always trying to interact with people in the lab. So it's not a very strict. That it's difficult to really put a big number on it, but I do think that as I mentioned before, some regimentation in terms of scheduling when you're going to meet with people, etc., ensures that you spend time thinking about each one of the projects in the lab. Because if you just do it sort of ad hoc, there may be somebody who sits in the corner for 6 months or a year where you're not paying any attention to their project at all.
I mean, especially with grants, it's so stochastic. At this time of year, it's 100%, and at other times of year, it's 0%. So it's hard to average it out. It depends on whether it's successful or not. I don't have quite as much administrative limits as Sally does, but I have a fair number. So I probably spend maybe between 30 and 40% of my time on pure administration. And I also have fairly heavy teaching load, especially this semester. I have 400 students. So that's probably about 40% of my time. So there's 20% for everything else right now. But that's not going to be true in the fall or the summer.
Plus it depends on how much time, it's all percent, it can be a percent of almost infinite. It depends on how many hours you work too. So, this also has to do with like how old if you have a family, how old your kids are. Like I can work nights and weekends. My kids are older teenagers, one's in college. So you just have, a different dynamic, and you can spend a lot more time at certain points in your life than at others.
But as a mentor and also co-important is for this kind of publications. I myself have been able to work with PIs who are very established, but I have other postdoc friends who work with the lab where the PI is just starting themselves on themselves, and they are working with other labs. So they need the publication and the postdoc or the graduate student also needs the first scholarship. How do you handle?
At least in biomedical fields, most of the time the PIs are perfectly happy being last off when opposed to the training being first off.
Other labs want to be at the bigger labs that the younger PIs working with. They want to be last.
Oh, they're collaborating with another lab. I see what you're saying.
Yeah, I mean, I think, in those settings, I've actually had occasion to be co-equal last author because of that situation where I'll have, a trainee, for instance, I'm training someone who I've been in my lab, and, where it doesn't matter, which one of you is last, if you start a local result for the corresponding author. Again, then when you go in for your grant renewal or whatever, you can asterisk and say, this was an equal contribution from two labs. And then I like to see the trainee be the first author.
There was in cases like this, we just swapped out where maybe there were going to be 3 publications. Say, all right, I'll take last author on this one, but my student be first author on that one, and you could have both on the third one or something like that.
And we are officially out of time, so I will